In this video, we'll look at doing a thermal solution on the basic geometry of our heat sink that we previously created to try to maximize the efficiency of the design. I've already created the geometry previously, so I'm going to open that real quick. And here we see the minimal viable product, that is the provided cube and cylinder of aluminum simply attached together. The uh, first thing to do when creating your solution is make sure that you actually select all of the parts that you want it to be applied to. So I can just hit Control A on my keyboard to easily make sure that it grabs everything in the workspace, or if you prefer, you can click and drag around the entire object to select it that way. Creating the solution, make sure it's the thermal option, and from the default materials, we'll pick the one that most closely matches what we're working with. The material properties of the actual aluminum might be different than the default here, but we can always go back later and edit those real easily and see immediate changes to our solution. We do need to define basic boundary conditions here for it to be able to show us anything useful. In particular, we have to tell it either a heat flow or temperature of one of the objects. So I'll select the cylinder here and set it to a temperature of 100 degrees Celsius. In our trial tests, that will be in boiling water, so that's pretty close. The whole rod may not be submerged in the water, but this will give us a good approximation. So we're already getting visual feedback in terms of the heat temperature over here, the coolest being on the very top of the cube, like we might expect. Also, how it knows what that temperature would be is based on the conditions of the ambient surroundings. By default, it's got the room temperature set to 20 degrees Celsius, which is pretty standard. We could always adjust this value, and also the convection in the air. So it's not just losing thermal energy through radiation, but the convection value here we could later go and adjust if we wanted to make it match different conditions. The main thing we're looking at is how design changes might increase the heat flow on the top of the cube. So I'm going to select all of these and add a probe to the entire top of the cube. If I only clicked on a single face, it would just track that face, and we really want to see how entire changes to this body might affect the effectiveness. When I clicked and dragged around the top here, it did include this circle on the top of the cylinder, which I actually don't want to include because I'm going to assume that's the 100-degree temperature of the cylinder. To remove that, if you hover over deep geometry like this in Discovery Live, you can use the scroll wheel on the mouse to move inwards. So I went up one click and now it thinks I'm looking at the bottom face of the square. One more click and now it's looking at the circle. If I hold down Control on the keyboard and click that, it removes that from the selected group that I had. So now it's just all the faces up top without that circle on the bottom. To that, I want to add a probe. So it doesn't have that pop-up option for me right now, but I can get it by right-clicking. In addition to all the right-click things, it pops up this contextual menu. I'm going to make sure that we get heat transfer on face. We want to know how much thermal energy is moving through those faces out to the environment. Gives me this nice little graph to track changes as we make modifications to our design. We haven't made any yet, so there's nothing on the graph. You can always collapse this and just look at this value and see how it changes over time. The units that it's using is watts, and that's tracking the number of joules per second of thermal energy that are flowing through those faces. Let's make one design change to highlight something that we later will have to go back and correct, but I just want to point out why we'll know there's something fishy going on. So I'm going to sketch a rectangle on this face to then use the pull tool and make a valley. So that should increase the surface area of the cube, and we'd expect that to increase the heat flow because there's more faces for it to interact with the cooler environment. So remember, first you have to click on the face that you want to sketch on. Then I'm going to click and drag a rectangle across this face. And if it's too hard to see your design there, you can always turn the solution off so you've got the full grid to view. And then I'm going to use the pull tool to push this in just an arbitrary amount for now. So here's what's unexpected. We increased the surface area, but the heat flow went down. It was essentially starting at 0, and now it's a negative heat flow. So that seems to have made our design less effective. The reason for that is because of how it's actually calculating heat transfer on face. We can take a close look at this if we right click on this over in the solution hierarchy and go down to edit the calculator. This is the parameters or the steps it's actually using to generate these numbers. So it is looking at the heat flux, which we want. That's the amount of energy going through an area, but it's only focusing on one component, the x component. If I look up at the axes here in our sketch, X is in and out of the screen right now. And when I pushed into that face of the cube, I actually reduced the amount of surface area, so there's less area for that heat to flow through. The solution to that would be to make it sum instead. So it's actually looking at all directions outward from the cube for that heat flow. And we'll leave it at normal. We could adjust this to be in a particular direction, but coming straight out from the faces will be pretty good with all things equal. So let's update that. And I'm going to go backwards in my design, and let's try making that change again. So now that I've changed the calculator there, even though I do Control Z on the keyboard to undo some changes to the design, it doesn't change the way that it's calculating the heat flow. It kept that at sum. And we see this time it did the exact opposite. So increasing the surface area of our heatsink here in any direction made the design more efficient. We're way up here in the positive values, so many watts of energy. I'm going to make a valley on the top of this as well, just to show that we would expect this to also increase the heat flow because we'll be increasing the surface area. And that again made a large jump up there in the efficiency, so that's good. Almost doubled what we had before. Oh, not nearly, up by a half at least. One more thing I want to point out, because I've heard a number of you brainstorming this, I'm going to show how to add some extra doohickeys on here, like fins or extra blobs of metal that you might want to put on there. If I just pick the side of the cube here and put a little extra box coming out, I could do that by sketching a rectangle on this face using the pull tool and pulling this outwards. Pull tool. You'll see something that jumps out at us right away is it's got a weird purple color. So that means it isn't actually being included in our thermal solution at all. And in fact, it tracked that as a design change, but says there was no change in the heat flow. That's because it doesn't include additions outside of our original bounding box as being part of the solution. When I remove stuff from the original object, it modifies that as being like inside the bounding box, so it will be automatically included, but these extra add-ons aren't. So one thing you can do is make sure you select them all. If I clicked and dragged and didn't catch all of the faces there, like this closest one is actually still purple, I could add it by holding Control and clicking on it to make sure I've got that whole shape. And then right-clicking will allow us to add it to the simulation bodies. So there, now it has included it, and again, we do see that that tiny little doohickey was quite effective. So adding a fin to the side looks like a good design choice at the expense of being harder to manufacture and including more material. Another option for including this that I'll show if I go backwards to where it was unattached, I just did Control Z on the keyboard, is you could click and drag to select the entire object plus some of the geometry behind it. And then use the combine tool under edit. That'll add it to the object, so it's all treated as one. And that automatically puts it back into the solution as well. So that was where we had successfully added it. I then did Control Z and removed it, and then added it here using the combine method. One pitfall with the combine method I should point out, as long as we're here, I'll go back again to where it was unattached, is when you click and drag to grab this, make sure you don't grab any part of the rod that was at a fixed temperature. If I'm not careful and I accidentally get part of the rod included, which you may not think you're doing because it's in the background there I did grab it, and combining those together, it actually broke my solution. Now I'm not getting any information back, and if I rotate it, you see it's removed all the color. That's because that cylinder was fixed at a 100-degree temperature. Now without any differential, it's just saying this is one object at one temperature and there's nothing useful that it can tell us. So you may run into that mistake, and it's why. So be careful about how you add on those extra doohickeys so that they're only on the top and not included to the fixed rod.